Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, I'm going to talk more about statistics, just like I did in the previous video. And here we are going to talk about measures of central tendency or measures of center. So let's begin. There are three measures of center, which are mode, mean, and median. And we're going to take a look at these three one by one. I'm sure most of you already know some things about this because this is something we all study in school. But still, we are just going to go through these once again, and you even get to learn something that you did not know about these measures. So the first thing we have is mode. And mode is very simple. So if you have data like this, and this is the data, that same data set I used in the previous video about different actresses getting the Best Actress award in Oscar, and we are trying to find what were their ages. So these are the different ages of actresses who got an Oscar between 1970 and 2030. And based on those ages, we have found out the frequency. So you can see different frequencies that for this particular age, how many actresses got an Oscar. So if an actress is 45, then how many actresses who were 45 years old got an Oscar between 1970 and 2013. And once we have found all these counts, we can show that 6 is the maximum count, and that count belongs to the age of 33. So 33 would be our mode for this data. 33 is the mode for this data set. So this is another example of mode. Data was collected here in this case from the last 3 World Cup soccer tournaments, and a total of 192 games were played. And this is the data collected, which shows which shows how many total number of goals were there per game and the frequency of those goals. So that means if there was a game played, let's call it game 1, then in that game 1, how many total goals were made? And then game 2, how many goals were made? Game 3, and so on. And then based on that, we have created this frequency table, which where we can find the mode, that the number of goals that were made, and that number which is the highest is 2. So 2 is the highest number of goals, not the highest number of goals, but the most number of times the number of goals were made in any game is 2, because those were made in about 51 of the games. Next we have mean. So mean is the average of a set of observations. So it's simply the sum of observations divided by the number of observations. And again, we can use the Best Actress Oscar winners example. And these are the different ages. And if you add them all up, you will get 1,687. And you can, of course, verify this by trying to add it on your own too. And there are total 44 values. So we can divide this number by 44 and we get 38.3. So the average age of an actress who can receive a Best Actress Oscar award is 38.3. So this is the mean of the data. Let's take another example of mean. So in this case, we are once again looking at the total number of goals per game and how many times that happened. So there were 17 games in which the number of goals was 0. And there were 45 games in which the number of goals was 1. and there were 51 where number of goals was 2. So like that, this is the table. And here to find mean, we have to apply a slightly different thing where we take a weighted average, not just an average, but a weighted average. So a weighted average means there is some weight associated with each frequency. In the previous example, there was no weight associated. It was just a bunch of ages. But now there's a weight. The weight is that 17 times games were played and the total number of goals in those games was 0. So that's why I need to write down 0 multiplied by 17, and then 1 multiplied by 45, and then 2 multiplied by 51, and so on. And then you add these values with the weighted average. So the weighted average, as you can see, is giving me 453. So 453 is the total, and the weighted average, that is the mean, is 453 divided by 192 because total number of games played were 192. And this gives me 2.359. So 2.359 is the average number of goals made in any kind of game played out of these 192 games in the soccer tournament. Now we are going to take a look at median. So the median, which is denoted by capital M, is the midpoint of the distribution. Like we used to find the center of a histogram, this is the same thing. And it is the number such that about half the observations fall above this point and about half of them fall below this point. And to find the median, we need to follow these steps. So first of all, you will order the data from smallest to largest. It is necessary that you sort the data in ascending order first. And then you have to consider whether the number of values you have is odd or even. And we call this number of values, number of observations, as n. And we find out if n is odd or even. If n is odd, then the median is the center of that ordered list. And this center you can find by simply doing n plus 1 by 2. And whatever value that is, on that position, n plus 1 by 2 is your median. But if n is even, then in that case, the median can be calculated by something that is between the n by 2th observation and the n by 2 plus 1th observation in the ordered list. So you will take an average of the two. Now this is how you can find a median. You can see in the example, first example, n is equal to 7. So the median is the fourth value because you just have to do n plus, you just have to do 7 plus 1 by 2, which gives you number 4. In the next one, n is 8, which is an even number. So in this case, you will do n by 2, which gives you 4, and then you will do n by 2 plus 1, which gives you 5. So you will take the average of the fourth and the fifth observations in order to get the median here. So let's find out the median of this data, which is the best actresses receiving an Oscar. So first of all, once again, we have to order this, and I have already written the ages here in an ascending order, starting from 21 to 80. And from there, you can say that n is equal to 44, which is an even number. So you need to do 44 by 2, which gives you 22. So you need to take the 22nd observation and n by 2 plus 1, which is 23. So you need to take the 23rd observation and take the average of the 22nd and 23rd. 22nd is 34 and the 23rd observation is 35. So 34 plus 35 divided by 2, their median is going to be 34.5. That's how you can calculate the median. Now let's see what is mean versus median. When should you use mean and when should you use median? So we have seen that mean and median are two most common measures of center, and each can describe the center of a distribution of values in a different way. So the mean describes the center as an average value in which the actual values of the data points play an important role. So the values, if there's a fluctuation in the values, then obviously mean will get affected with this because it's an average and it considers all the values. The median, on the other hand, it locates the middle value as the center, and then the order of data is the key to finding it. So only if that order changes, then the median gets affected. If there are minor changes in the values and the order does not change, then the median won't be affected much. So consider these two data sets. There's a data set A containing 64, 65, 66, 68, 70, 71, and 73. And there's a data set B which contains 64, 65, 66, 68, 70, 71, and it contains a really large value, 730. So for data set A, the mean is going to be 68.1 and the median is 68. You can verify this by calculating it on your own. And if you see the data set B, then all observations between A and B are same except the last one, which is 730 instead of 73, which is very large. And you can say it's an outlier because obviously if you make a histogram, this 730 will be somewhere far away from the other data which is plotted. So in this case, the median in data set B is still 68. The median did not change. And the reason for this is because the order did not change. The ascending order of the data is still same. And so the middle value is still 68. But mean is definitely going to change. The mean for dataset A was 68.1, but the mean for dataset B is 162, and it shot up to this range because of this extra value, which is really large, which is 730. So you see, mean gets very much affected by outliers, but median does not get affected by outliers. So this is the conclusion. Mean is very sensitive to outliers because it factors in their magnitude while calculating the average, but median is quite resistant to outliers. So based on all this, we can make some observations about mean and median and when to use them. And if you look at this graph, this is a symmetric graph with no outliers. In such a graph, the mean is approximately equal to M. Capital M stands for median. So mean is approximately equal to median when you have a symmetric distribution with no outliers. Take a look at this distribution, which is about the data set we used about ages of actresses who got the Best Actress award in Oscars from 1970 to 2013. So for this, it is a skewed right distribution because it is flat on the right side. And it does have outliers. It has many outliers, as you can see here. On the right-hand side, there are many outliers. So in such a case, the mean will be greater than the median. And another example is a distribution that is skewed left. So it is flat on the left side, but it is rising towards the right-hand side. So for such a skewed left distribution and a data set with less number of outliers, the mean is less than the median. And so finally, we can conclude from all this that we can use median as a measure of center when the distribution is symmetric with no outliers. But if you see a histogram where the distribution is not symmetric and there are a lot of outliers, then to measure the center of such a histogram, median will be a more appropriate concept. So this is everything you need to know about mode, mean, and median. And we'll continue this introduction to statistics and probability in the next video. So I'll see you there, and thank you for watching.